Hello everyone, welcome to week 2 lecture videos. In this video, I will be discussing learning objective 2. That means we will basically discuss different utility preferences and their implications for portfolio evaluation. So understanding utility preferences is really important when we evaluate value of a particular investment portfolio. We previously discussed that all investors seek to maximize utility. And utility itself is an abstract concept. So we also previously discussed the idea of mean variance utility being the key measure of utility for most of the financial analysis. However, now we will be discussing some other utility functions. So for all these utility functions, for example, prospect utility, habit utility, and non-financial utility, for all other alternative utility functions, mean variance is the starting point. However, we look utility in different ways under these different utility functions. First of all is a prospect utility. So the main notion or the idea of prospect utility is that investors treat gains and losses differently. Okay, so under the mean variance utility, we assume that investors symmetrically treat the upside potential and downside risk. However, under the prospect utility, we assume that investors treat gains and losses differently. That means the danger of downside risk and opportunity for upside potential is a separate element. This is intuitive and this have important implication for portfolio investment. Since investors treat upside potential and downside risk separately, so they actually are more concerned about downside risk than the upside potential. Okay, so if an investment alternative has same degree of upside potential and downside risk compared to another investment alternative which has a higher upside potential compared to downside risk, definitely investor will prefer the second one. Okay, that means investor try to avoid investment that has higher downside risk. Then the second one is habit utility. The idea of habit utility is that investors get used to particular level of consumption. Each investor has a particular level of consumption, and investors become more risk averse when they get closer to this particular consumption level. And investors are ready to take more risk when they get away from this consumption level. And last of all is non-financial utility consideration. So non-financial utility consideration states that investors are not only concerned about the mean and variance, that means they not only try to maximize their return and minimize their risk, sometimes they may prefer or they may get higher utility for investing in socially responsible investment alternatives. For example, they avoid investing in companies that produce arms, tobacco, or cigarettes. So even if for investing in companies that excludes those, may provide them a relatively lower income, but still they prefer them and they get higher utility from them. Now, as we have previously discussed in our learning objective 1, that if excess return is normally distributed, then portfolio management becomes easier as half of the returns lies in the right hand side and half in the left hand side, so upside potential and downside risk are symmetric. However, if excess returns are not normally distributed, then apart from mean and variance, higher moments of return distribution become relevant. In that case, we also consider skewness and kurtosis. So, as a starting point of the mean variance optimizer, we depend on mean and variance. However, if investors are not mean variance optimizer and they consider the higher moments, then we also estimate skewness and kurtosis. So what is skewness? Skewness is the symmetry of the distributions. That means how symmetric the distribution is. In a normal distribution, it is perfectly symmetric. So half of the returns lies in the right hand side of the mean expected return, and half of the returns goes in the left hand side of the expected return. However, if return is not normally distributed, in that case skewness will be non-zero, so it might be positively skewed or negatively skewed. Positively skewed means there will be chances of higher positive returns without a corresponding chance of negative returns, and if it is negatively skewed, there will be higher chances of negative returns without a corresponding chance of positive returns. And kurtosis is the possibility of extreme returns compared to the returns we expect from a normally distributed return series. Now look at this example. Here we have three curves and three distributions. Each has a mean of 6% and standard deviation of 7%. However, you can see the light pink curve indicates a normal distribution. So it has a skewness equals to 0, and half of the distribution is right of the expected return and half of the distribution is left of the expected return. However, if you look at this black line, it is a positively skewed curve, so it has higher positive returns and it has a fatter tail in the right, so there is a chance of higher positive returns without a corresponding chance of negative returns. On the other hand, the dark pink curve, it has higher or larger negative returns, so it is skewed negatively, so there is a chance of larger negative returns compared to without a corresponding chance of positive returns. So what is the implication of this skewness for the portfolio investment? The implication is the investor will like a positively skewed distribution. Investor will get higher utility for a positively skewed distribution because there is a chance of higher positive returns without a corresponding negative return. So investors will be willing to pay more for a stock that has a positively skewed return. On the other hand, investors try to avoid negatively skewed return and they get less utility from negatively skewed return, and they will be willing to pay less from negatively skewed return because it has chances of higher negative returns without a corresponding chance of positive returns. Now let's see some example. This is a return distribution of the United States from 1926 to 2005, and you can see that there are more negative returns compared to the positive returns. So the US return exhibit a negative skewness. And what about Australia? This is an Australian evidence from 1970 to 2015, and also you can see that there are more negative returns compared to positive returns, and we also calculate skewness, it's negative. Now, as I already told you, that skewness preference is very important for investor because investors prefer opportunity and they try to avoid downside risk. So when an investor finds a stock with the positive skewness, they value this higher opportunity and they will be willing to pay more. Whereas when there is a stock that has a negative skewness, which has a higher downside risk, investor will be worse off for investing in that, so they will be willing to pay less. And this is an example of lottery ticket. You know that lottery ticket typically have negative expected return and they are typically negative net present value investment. However, still investors invest or buy lotteries. The question may come, why? The investor buy lotteries because it has a positive skewness type of distribution. Because you understand, when we buy a lottery, we pay a certain amount and we expect to get a very high return, but there is no corresponding probability of losing. That's why it has a positive skewness and investor like to buy it. Investor pay more for this type of positive skewness distribution. And another example is the prices of out-of-money put options. You know that put option is a right to sell. And when we buy a put option and we lock price, so we will be able to sell a certain stock when the market price goes down. And ideally, the price of a put option should be determined by a theoretical model. However, we typically see that the price of put option in the market is relatively higher compared to the price that is determined by a theoretical model. The reason is why? The reason is since the put option protects investor from selling the stock at a lower price and protect from the downside risk, investors are willing to pay more for a put option than the price that is suggested by a theoretical model. So that's our discussion on learning objective 2. Please watch the next video for our discussion on learning objective 3. Thank you very much.